We're going to go ahead and take a look at 1.5. We're going to be continuing our journey with integers here and looking at some different integer operations. So this is a list of how we're going to multiply and divide real numbers. So last we added and subtracted. Now we're going to multiply and divide those real numbers. By real numbers, we mean positive and negative numbers. When we multiply two numbers, it's called the product. When we multiply positive numbers, we get a positive number. We also know that 0 times anything is going to be 0. That's going to be called the multiplication property of 0. So we're going to formalize that and give it a name. But what happens when we have a positive number and a negative number? For all values of x and y, if I multiply a positive number times a negative number in any manner, the answer is going to be negative. It doesn't matter the order that they're written in, I'm going to get a negative answer. So 6 times negative 3 is negative 18. I want to take this a step further. If there are an odd number of negatives in the multiplication, the answer is going to be negative. There is one negative in this example. 1 is odd, the answer will be negative. That's going to be important as we progress in the course. In A, I have one negative number, 1 is odd, my answer is negative. And I'm just doing this straight multiplication. B, I have one negative, and that's odd, so that's going to give me a negative answer. In the Web 2.0 calculator, when you go ahead and do the multiplication of the 16 and the 5 over 32, it's going to reduce the fraction for you to negative 5 over 2. So you don't need to worry about doing that manual reducing of fractions. If you're awesome at fractions, definitely consider doing it by hand, but Web 2.0 will take care of that for you. What do I do when I have two negative numbers? When I have two negative numbers, the product is going to be a positive number. I want to take that a step further. If there are an even number of negatives in a problem, the answer will be positive. So negative 5 times negative 4 has two negative numbers. 2 is even, my answer is positive. The same thing applies to A and B. There are two negatives in the problem. 2 is even, so my answer is positive. You can type negative 3/4 times negative 2/5 in Web 2.0 and get 6 over 20. Why do you have to know the rule? Well, we have to know the rule because when I start saying negative x times negative y squared, I have to know that's going to be a positive. So we're going to be moving towards variables and things our calculator cannot do. And Web 2.0 will actually give you the fully reduced 3 over 10. So this is going to be just an extension of what I've been saying. If I'm multiplying numbers, if there's an odd number of negatives, it's going to be negative. If there's an even number of negatives, it's going to be positive. When I'm factoring this, I have to take that into account. To get 18, I could do 1 times 18, but I could also do negative 1 times negative 18. So we have to expand what we know about factoring numbers to include integers. And this is going to be very important as we approach quadratic equations. So every positive number has a pair of factors. So notice how these are paired. Negative 1 times negative 18 is the same as this. Negative 2 times negative 9 is paired with this. So what we've done is taken every number we can factor and we've expanded it out to include these pairs. Now, we can use things with division to use a reciprocal. A reciprocal means we're flipping the fraction. So 4, at first you say, well, 4 is not really a fraction. Well, it is. It's 4 over 1. So the reciprocal of 4 over 1 means to flip it and get 1 over 4. You don't change the sign. You just change the order of the fraction. So negative 5 is negative 5 over 1. The reciprocal does not change the sign, and it becomes negative 1 over 5. If two values are a reciprocal, then they would cancel out. So 5 times 1/5 would be 1. But what happens when I start looking at other values? So we're going to start thinking about division as a reciprocal. I know you're thinking, why is this important? It is important when we start dealing with variables. So we're defining division a little differently. So 15 divided by 3 becomes the multiplication of the reciprocal. 3 over 1, the reciprocal would be 1 over 3. So notice how the sign changes from division to multiplication. Again, this is so very important for later on. The same thing occurs with division that we see occurring with multiplication. If there are an even number of negatives in the problem, the answer is positive. If there are an odd number of negatives in the problem, the answer is negative. So negative 15 divided by negative 3, there are 2 negatives. 2 is even, my answer is positive. At negative 15 divided by positive 3, there is 1 negative. It's an odd number of negatives, so it's going to be a negative answer. These are some example problems you can practice. When I divide 2 negatives, I get a positive. 1 negative, 1 is odd, a negative. And then I have divided by negative 2/3. We're going to take that division, rewrite it as multiplication. So flip. When we flip, we don't change the sign. So now I have 1/4 times negative 3/2. My answer will be negative. Here's where we have a common error with division of 0. 0 divided by anything is 0. 0 over 2 is 0. It is not undefined. 0 in the denominator is when it's undefined. So this is a common place where students get a little confused on their final answers. The 0 has to be in the bottom to be undefined. So here we're saying if there is an odd number of negatives in the problem, it doesn't matter where they are, it is going to have a negative answer. Negative x divided by y is the same as saying negative x over y or x over negative y. The convention for a fraction is to write the negative in the front in your final answer. The lab is going to force that. You need to make sure you're putting the negative in front of the fraction. It doesn't matter if the numerator is negative or the denominator is negative, it needs to go out in front. If both the numerator and the denominator are negative, that's 2 negatives, 2 is even, your answer is positive. So be really careful in the lab with how you're entering your answers because this is very specific and it's needed for later on in your algebra journey. So now we're going to look at the order of operations. We're just going to add other functions into that multiplication. Negative 3 times positive 4, 1 negative. Minus 2 is seen as negative 2, guys. Minus 2 is seen as negative 2. That's why it becomes positive, because negative 2 times negative 6 has 2 negatives, therefore it is going to be a positive answer. Then in part B, same thing applies. 2 negatives make a positive, 1 negative makes a negative. I get negative 21 over negative 14. Why is the negative in front? Because 48 minus 27 is a positive number. But I have divided by negative 14. I don't write the negative 14 in the denominator. I put the negative in front. And then I reduce the fraction. Web 2.0 will do this for you if you need help. You do 21 divided by 14. It will reduce it to 3 over 2 for you. Now I'm going to evaluate. Remember that word evaluate means plug in. When I plug in, look at this, what I said in 1.1, you have to use parentheses, and this is why in the earlier lectures I was saying to use parentheses, because negative 2 squared inside of the parentheses is a positive value. That is exactly why I was stressing the use of parentheses. And if you type this in your calculator as open parentheses, negative 2, close parentheses squared, it will give you the positive number. That's why it's so important to use those parentheses. When we are translating words and phrases, we did addition and subtraction. Now we're doing multiplication and division. I strongly encourage you to copy this table down, pause the video so you have it as you're looking at the problems. The order of multiplication does not matter very much, but the order of division does matter. So this table is just giving you the words that you can use for multiplication where the order you're doing them in is not important. But in the next section, when we see division, the order we're doing things is going to be important. So here are some practical examples. 3 times the difference between 4 and negative 11. When I have difference between, that's that same thing as the word of. I'm indicating a grouping symbol. So I have 4 minus negative 11 because it's the difference. And remember, if you go back to your subtraction table, difference is going to be in the same order as the numbers appear. I'm going to use my order of operations. I'm going to do 4 minus negative 11, which is plus positive. So I get 4 plus 11, or 15. Then I do the multiplication. 3/5 is 3 over 5. And the sum of implies grouping. You could use parentheses or brackets here. It's not specific to needing to use brackets. Here's our division table. The division table is important because the order in which we divide things causes answers to be different. So you want to make sure you copy this down in your notes, pause the video for just a minute so that you have this to refer back to in your notebooks. If I'm writing a numerical expression for the phrase and I'm simplifying, I would say something like the product of negative 9 and 2 divided by the difference of 5 and 1. That divided by is implying I've got groups, but I'm dividing by, and that's implying a fraction, okay? So I have the product in the top, the subtraction in the bottom. I'm then going to use my rules to simplify it. This is probably going to be the place in the lab that causes problems, so I would do a couple of practice problems in the textbook in this section 1.5 and check your answers using the odd phrases, or send me a message if you're not sure. That's really going to help you understand when we're grouping things and how the order of things is happening. These are some more examples of taking the words and putting them into a symbolic formula, because again, no one's going to walk up to you in real life and say, hey, what is 6 divided by 3? No one's going to ask you that. That's going to be something that occurs in a problem or in a situation where you're trying to solve for something. So these are just the expressions of what they would mean. So I have the quotient of a number being x, and negative 2 is 6. So equality is implied by that word is, or it could be given potentially, but is typically what we use. Twice a number, 2x from our multiplication table, is 6 equals negative 6. And that's the end of 1.5.